Greetings. This is the group of Ayo, Aprajita, Chirayu, and Joey, and we are here to present on the NoSQL Redis. The basic flow of our presentation is going to be as follows. We're going to start with the basic difference between SQL versus NoSQL and share features of them as a big group. Then we're going to move to history of Redis, where I'm going to tell you who developed Redis, how it came into production, when it was sent into production, and then how did it follow through the history. Then I'm going to move to the basic features of Redis, after which I'm going to list some industry users of Redis and what its basic uses are. Then I'm going to move to a few steps of installation and then how you can start and use the application. After that, we move to connection, architecture, and the basic data model where we describe the different data types that Redis handles. Upon which we're going to move next to the basic atomic operators in Redis and show you some simple queries and make you understand how they work. The basic queries that we're going to go through are how to select a database, the set and get examples, there are exist and delete examples, there are some list examples, and then we move to transactions. Then we move on how to scale Redis, which is a very important topic as it's very easy to scale Redis, and that's why it's in major use in the industry and independent development also. After scaling, we're going to compare Redis versus MongoDB, which is another leading NoSQL in the market. After that, we are going to move to explain you how to use and when to use Redis. Then we just have a slides to tell you all our references, which proves that our research was credible. SQL versus NoSQL. SQL is a standard language for dealing with relational databases which defines relationships in form of tables. On the other hand, NoSQL is non-relational database that doesn't require a fixed schema, avoids joins, and is really easy to scale. SQL databases have tables with fixed rows and columns, while NoSQL databases maintain key value pairs, and SQL databases were developed in 1970s with a focus on reducing data duplication, while NoSQL was developed in late 2000s with a focus on scaling and allowing for rapid application change driven by agile and DevOps practices. Some examples of SQL databases are Oracle, MySQL, Microsoft SQL, Server, and PostgreSQL. Some examples of NoSQL databases are MongoDB, CouchDB, DynamoDB, Cassandra, Redis, Neo4j, and Amazon Neptune. The primary purpose of SQL databases is very general, maintaining tables, maintaining relations, how they connect to each other, querying them, and so on and so forth. They are very useful. However, the primary purpose of NoSQL databases is maintaining key values for large amounts of data with simple lookup queries. The schemas in SQL are very rigid while being very flexible in NoSQL. As I mentioned, scaling is really easy in NoSQL, and they typically don't require joins while SQL typically requires joins. History of Redis. Redis project was started by Salvatore Sanfilippo in the early 2009. He found that MySQL couldn't provide necessary functions while working on a real-time web analytics solution. Redis was deployed in production in June 2009. Sanfilippo was hired by VMware in March 2010. In May 2013, Redis was sponsored by Pivotal Software, which was a VMware spin-off. In June 2015 later on, the development became sponsored by Redis Labs. Eventually, in June 2020, Salvatore Sanfilippo stepped down as a Redis maintainer. Basic features of Redis. Redis is an advanced key value store where keys contain data structures such as strings, hashes, lists, sets, and sorted sets. Its name, Redis Remote Dictionary Server, is an in-memory it suggests is an in-memory data structure store used as a distributed in-memory key value database, cache and message broker with optional durability. Redis supports different kinds of abstract data structures such as strings, lists, maps, sets, sorted sets, as I mentioned earlier, and also bitmaps, streams, and spatial indices. Redis is very different from other database systems. It popularized the idea of a system that can be considered at the same time a store and a cache, using a design where data is always modified and read from the main computer memory, but also stored on disk in a format that is unsuitable for random access of data, but only to reconstruct the data back in memory once the system restarts. User commands in Redis do not describe a query to be executed by the database engine. Rather, they are specific operations that are performed on given abstract data types. Hence, data must be stored in a way which is suitable later for fast retrieval without the help from database system in form of secondary indexes, aggregations, or other common features of traditional RDBMS. The Redis implementation makes great and heavy use of the fork system call to duplicate the process holding the data so that the parent process continues to serve clients while the child process creates a copy of the data on the disk. There are multiple advantages of how Redis is structured and how its basic features come together. Redis is written in C and is really fast. It allows storing key and value pairs as large as 512 megabytes. Redis uses its own hashing mechanism called Redis hashing. It offers data replication. Replication is the process of setting up master-slave cache nodes. The slave nodes always listen to the master node, which means that when the master node is updated, slaves will automatically be updated. Redis also has the functionality of being able to update the slaves asynchronously. The Redis cache can withstand failures and provide uninterrupted service. Redis has clients in all popular programming languages, which means it has client APIs developed in all of the popular languages such as C, Ruby, Java, JavaScript, and Python. Redis allows inserting huge amounts of data into its cache really easily. Redis protocol makes it simple to implement a client. And last but not least, Redis also supports transactions. Moreover, don't confuse Redis for being a replacement for a relational database. Rather, it can be used complementary to a SQL store or NoSQL store. For instance, you can have a MySQL database or any other SQL or NoSQL language database and use the NoSQL Redis in complement to it, not as a standalone NoSQL database. I just listed the basic features and high advantages of Redis. Industries want to use Redis to put it to its most advantageous usage and use all its features to gain the most profit out of it. The biggest users of Redis in the industry are companies like Twitter, GitHub, Weibo, Pinterest, Snapchat, Stack Overflow, and Craigslist and Dig. Companies like Flickr also use Redis. Till now, we talked about what Redis is, why it was needed, why is it useful, the basic features, how it came into development, the history, and who uses it in the industry. Now let's get hands-on with Redis. The first step with any software or any new thing on a computer you would do is downloading and installing the software. For Redis, on Mac users, it's pretty much very easy to simply download Redis using Homebrew and use it directly. Otherwise, there are two ways that you can download Redis. The first way is to download a tarball from redis.io. The other one is use the URL presented on the PowerPoint and go to the link to download a tar file. After you have downloaded that on your computer, follow the steps. Use the command wget and then mention the URL from where we downloaded the tar file. This tar file is basically like a zip file. We need to extract the contents in it to be able to use Redis. To be able to do that, you have to use the command tar with the options x, v, z, f, and then space redis-stable.tar.gz. After that, your files have been extracted. Now you need to change your directory to be able to go into Redis stable. To do that, you need the command of change directory, which is cd space redis-stable. Once you're in there, you can just use the make command to finally have it. Now that you have downloaded Redis, let's see how to start and check if Redis is working. To start the Redis server for development, simply use the command redis-server. This will deploy the Redis server and you'll be able to use the server when you plug in a client. To use Redis for production environment, you will need to use the configuration file. Therefore, use the command that is present on PowerPoint. It goes as follows: redis-server space etc space /etc/ redis.conf. This is the configuration file for Redis. To check if Redis is working successfully, use the command redis-cli ping. This would give you a response pong if the server is successfully running. Now that you have successfully installed and started Redis, it is very important to make sure that the Redis environment you're using is secure. The steps for doing that are as follows. Make sure that the port Redis is using to listen for connections is firewalled. Guarantee that Redis is only listening on the network interface that you want it to by using a configuration file where the bind directive is set. Use the require pass option in order to add an additional layer of security so that the clients will have to authenticate using AUTH command. Use spipe or another SSL tunneling software in order to encrypt traffic between Redis servers and Redis clients if your environment required encryption.
Installation using Redis from application. To use Redis from an application, you would need to install a Redis client library for your programming language. And you can find a full list of those clients for the different types of languages in the link below. In that link, there are different types of languages like Java, SQL, and Ruby, and many more. You would just go on that link, find it, and then try to find the client you would use. For example, in Java, there's Redis, there's Java Redis Client, and there's Redis. So just go on the link and find the one you want to use. Installation persistence. So if you use Redis with the default configurations, Redis will only save it after you've made huge changes or after a certain amount of time, like maybe 10 minutes. So if you want your database to persist, you need to use the save command manually after every time you want to save your data set, which would then force a data set snapshot. Or you can just make sure to call the shutdown command when you're done. And the command is as shown below, redis-cli and then shutdown. And there are many more options you can use to persist. There's RDB, AOF, the combination of RDB and AOF, and of course there's no persistence, which is just using Redis with the default configurations. Connecting to a server port on Redis. So by default, Redis connects to this IP address at that port number. And if you want to change your server hostname or IP address, you need to add the -h to your command. And if you want to change the port number, you need to add the -p to your command. An example is shown on the slide. So we have redis-cli-h then Redis 15.localnet.org-p6390 ping. So the ping here is to test the connection to make sure it's connected, and it should return a pong. So in this example, we're setting the server/IP address to the server IP address to the Redis 15.localnet.org, and then we're setting the port number to 6390. And that is an example of how you can connect to a server port on Redis. How to create a master slave connection. So the first step, if you want to create a master slave connection, is to find the host and the port of the server that you want to use as the master. And then you need to update the Redis configuration file on the server that's supposed to be on the slave. So you need to get the host and port number of the master and then update that on the slave. So you need to find the line that says slave of host port, and then change that host to the host name you found, and then the port to the port number you found for the master. And then you can also do this by running the slave of host port command in an existing server, but just be careful. Doing this will delete all the data that's already on that server and replace it with that of the master server. And if you wanted to disconnect a slave from a master, you just call the slave of no one, and that would disconnect it. And that's just an example of how to create a master slave connection. Architecture. So Redis has two main processes. There's the client and the server. You can run both the client and the server on the same computer or on different computers. Just let you know that. The architecture supports RDB, which I mentioned in persistence, which is just storing the copy of the data in memory and then storing the copy of all the data in memory into a permanent storage. And then there's AOF, which logs all the write operations that's received by the server into, it logs it, and then when Redis restarts, it re-uploads it again, which makes the data persistent. And then there's the save command, which forces Redis to create the RDB snapshot at any time the save command is used. And that's just a little bit about the architecture. So there are different data models. Well, no, so there are different data types, not models. But Redis is a data structure server that supports the different kinds of values. So Redis is not limited to simple strings. You can use it for more complex data structures. And the different data types in Redis are strings, lists, sets, sorted sets, hashes, and bit arrays. There's also another one called the hyperlog, but we won't be talking about that in this presentation. But Redis is a key value store. So the keys in Redis are binary safe, which means you can use them with any binary sequence. For example, you can use the string foo as a key, that's fine. But you just need to note that the maximum allowed key size is 512 megabytes. And some rules for setting your keys are that you can't use a key that's too long or that's too short. So you need to find the balance between those and that you have your key. And then moving on to the different data types, we have strings. Strings are the simplest type of value that you can use with a key. So strings the Redis string can contain any kind of data like a JPEG image. The maximum length of it is 512 megabyte. And there are multiple things that you can do using strings in Redis. For example, you can use strings as atomic counters, which we'll be talking about later on. But you can use commands like increment, decrement, increment by, and yeah, there will be examples on how to use different types of commands like that later on. You can also use append command to append to strings because the string works like an array. It's like a string array, so you can append to it. And then you can also use strings as a random access vector with get range and set range. There are different types of things you can do with strings. You can find more information on that on the Redis documentation. Lists. So Redis lists are just lists of strings that are sorted by insertion order. So it's not sorted in alphabetical order or ascending or descending order is sorted by insertion order. The maximum length of a list is 2 to the power of 32 minus 1, which elements, which I believe is about 40 million or so. And so some commands in this are lpush, rpush, or lrange. So if you wanted to use lpush, what that would do would just add an element here. Like you would push whatever element is here, push it back one and add it in front of that. And then rpush would add an element back here. So you push this up one and add that element there. And lrange, you can just use it to get recently inserted elements. Like we just inserted an element into the tail of the list, so we'd get that element that was just inserted. And yes, that is, you can also find more information on this on the Redis documentation, and there will be some examples of more commands in the atomic counter later on.
Data model sets. Redis sets are unordered collection of strings. You are able to add, remove, and check if an element exists in the set. Maximum number of elements in a set is 2 raised to the power 32 minus 1 elements. Some commands are sadd and sinter. Sadd is used to add specified members to the set sorted at key. Sinter returns the members of the set resulting from the intersection of all given sets. Could also be intersect. Smaller sinter is a small word for intersect. So center, yeah. Data model sorted sets. Redis sorted sets are very similar to Redis sets. Difference is that every member of a sorted set has score that is used to make the sorted set ordered from smallest to greatest. So it sorts it in ascending order. Some commands are zadd, which is used to add all the specified members with specified scores to the sorted set stored at key. zrank returns the rank of a member in the sorted set. zrange by score returns all the elements in the sorted set with a score between min and max. There is also a diagram towards at the right side of the screen to help you visualize that. Data model hashes. Redis hashes are maps between string fields and string values. A Redis hash is sorted in a way that takes little space. Every hash can store up to a maximum of 2 raised to the power 32 minus 1 field value pairs. Some commands are hdel, used to delete one or more hash fields. hgetAll, used to get all the fields and values in a hash. Data model bit arrays or bit maps. Bit arrays are a set of bit-oriented operations that are defined on the string type. Bit arrays are suitable to set up to 2 raised to the power 32 different bits. Some commands are setGet, getBit, which is used to set or get the bit single bit operations on binary operations. BitOp performs bitwise operations like and, or, not, etc. between different strings. Bitpause finds the first bit having the specified value of either 0 or 1. Atomic operators. Some atomic operators that work in big O of 1 time complexity are as follows. There are strings like get key, set key value, exists key, del key, sets like sadd, srem, scard, spop key, sorted sets like zcard key, hashes, hget key field, hset key field value, hexist key field. Get key gets the value of a key. Set key value. This command sets the value at the specified key. Exists key returns 1 if the key exists, or 0 if the key does not exist. Del key could also mean delete key, which removes the key that holds a string value. Under the sets, sadd adds 1 or more members to a set. Spop removes and returns a random member from a set. Srem, or you can also say it as sremove, it's srem, removes 1 or more members from a set. Scard gets the number of members in a set. Zcard gets the number of members in a sorted set. Hget gets the value of a hash field stored at the specified key. Hset sets the string value of a hash field. And hexist key field determines whether a hash field exists or not. Atomic operators. Some atomic operators that work in O(n) time, big O of n time algorithms are under sets, set sdiff, which subtracts multiple sets, so it would subtract key 1 and key 2. Union adds multiple sets. Union means adding. So hashes, HMget gets the value of all given hash fields. Hkeys gets all the fields in a hash. And hvals gets the values in a hash. Some atomic operators that work in big O of log n time. Under sorted arrays, zadd key score member. Zadd adds 1 or more members to a sorted set or updates score if it already exists. Zrem removes 1 or more members from a sorted set. Zrank determines the index of a member in a sorted set. Some atomic operators that work in big O of log n plus m time complexity are zrange, that returns a range of members in a sorted set by their index, and zrange by score, that returns a range of members in a sorted set by score. Databases are not created with a command, and the default is 16. They switch between the 16 different databases using the select command. So if you're using a database, you'll right select, and select the database name of your database.
Now that we have gone over some basic commands, I'm going to run you through some examples to help you better learn them. Try to give them your best shot. Doesn't matter if you get them right, as well as it's just a review. So to start off, to actually execute a command, you're just going to type in normal. There's not really any special you have to follow the syntax that's given, but there's not any special way to enter the command. So for the first example, if we're going to want to set a string hello under the key my key, I'm going to give you a couple seconds to try to figure it out. I'm going to do that for the rest of the examples. Okay, hopefully you got it by now. The answer is just set my key hello, with the set being the command, my key being the name of the key that you're creating, and hello being the value within the key. Now if we want to retrieve the value being hello from the key my key, you're going to run this following command. Get my key. The output is just going to be in this case, the string hello, as that's what we assign to the value of my key. Now, if we were to reassign the value to my key to the word world, what command would we use? In this case, we would just use set my key world again, as the set key will always override if the key name is the same. You can also assign many keys with values in the same statement using mset, and basically it separates key, value, key, value, key, value, with spaces in between differentiating them. You can also do the same thing to retrieve values using mget with spaces in between the key names, and the output will print them in the order that you specify the key names. Now I'm going to go over the exists, type, and delete examples. So if you want to check that if a key under a specific key name exists, you're going to run this command as we've described earlier. The command is just going to be exists and then the key name. In this example, we're using my key from the previous. The output would either be 1 or 0, 1 meaning that the key does exist and 0 meaning that it doesn't. Next, if you want to find out the type of the key, where you just specify type and then the key name, and the output will be the type of the key. In this case, it's string because my key, as we last defined it, is set to world, which is a string. Next, if you want to delete a key and a value, you just type del and then the key name. In this case, is my key. And if the output is 1, then the value is deleted. If the output is 0, then for some reason the value would not be deleted. And lastly, we're going to check if the key exists one last time. And in order to do that, we're just going to run the same command as the beginning, exists my key. And in this case, the output is 0 as the key no longer exists because we just previously deleted it. Next, I'm going to go over some list examples. Lists use the commands lpush, rpush, rpop, and lrange. These are just some basic examples to give you a general feeling of how to use lists using Redis. So the first command is rpush, and basically this command pushes the value onto the right or the end of the list. An example being rpush mylist with the key for the new list that we were creating being mylist, and the value we're pushing onto the right being a. The output is just going to be the integer number of how many values are within that list. So right now the output's going to be 1, and currently my list just contains the value a. Next we go on to lpush. This pushes the value to the left or the beginning of the list. An example of this is going to be lpush mylist_b. We're calling into the same list as the previous example, being mylist, and then we're adding the value b. We're adding it to the beginning of the list. So right now the list is going to be the value b, then the value a, as b was just added to the beginning. The output is going to be the same as rpush with the integer value. Right now the integer value is going to be 2 because now we have both b and a within the list. Next is the lrange command. This starts counting from the first number given to the last number given from the key name of the list. An example being lrange mylist 0 to -1. In this specific example, the output is going to be all values in my list, in this scenario being b, then a. -1 represents the last element of the list, so if you don't know exactly the number, just put in -1 and that will be the last number of the list. 0 is the first, as a, or in this case, b is going to be index 0, and a is going to be index 1. Next command is rpop. Rpop basically removes and returns the most right element, or the last element in the list. An example is just going to be rpop, and we're going to use the same list we've been using. And the output is going to return a, as a is the last value in the list currently, as well as you're going to remove the value from my list. So currently, after this command, my list is just going to be the value b. Next is transactions. We're just going to do a brief overview of transactions for now. So the foundation of transactions in Redis are just like these 4 main steps, as well as there is one more that we cover in the next slide. These being multi, exec, discard, and watch. Transactions ultimately allow the execution of a group of commands in a single step, and also allow you to go back like those never happened. It's basically for security reasons, like you don't want to take away money without receiving it on the other end, and vice versa. All the commands in a transaction are serialized and executed sequentially, so they are executed in the order that they are stated. And lastly, the Redis transaction is atomic. Now I'm going to dive deeper into the 4 main commands of a transaction. So to start any transaction, you're going to call the command multi, and this is going to give an output of just OK, and this is going to begin the transaction. Then you're going to enter the following commands that you want to incorporate in the transaction, and these are going to be added to basically the exec command. Once you call exec, it's going to run all those commands sequentially in the order that you entered them. If you do not want those commands to be run for any reason, you can call discard, which is going to end all those, well, it's going to cut off all those commands and then just restore it back to normal. You can also call watch on a specific key, and basically what happens is if that key is altered in any way by the time exec is called, or before exec is called, then it is going to end the transaction and basically discard what happened. You can then unwatch a key that you have watched before if you don't want watched anymore. Next, I'm going to give a brief overview of how to scale Redis. If you don't know what scaling is essentially adding more servers or increasing the power of the servers you already have. You usually need to do this when you run out of space, like you have too much data or you don't have enough storage to store the amount of data you need. Or you need to perform more read-write commands, as each Redis server has a limit to how many read and writes it can perform. If you need more write commands, or you need more data, or you need more storage to hold your data, you want to make sure you do all you can to limit how much data you have to begin with, how many write commands you have, as to increase the amount of data and write commands is much more complicated than to just increase the amount of read commands. If you just want to increase the amount of read commands, you could split up the servers between master and slave servers. The master server is going to be the main server storing all the data, while slave servers are just servers that connect to that and can read the data from the master server. Slave servers cannot hold their own data, as all their data is just retrieved from the master server. Thus, this makes them very good for reading and getting more read commands. However, you cannot write to a slave, you can only write to the master server. If it is the opposite, where you need more write or data, then you're going to have to shard the data and split it up into multiple servers. Essentially, you're just splitting up the data amount and splitting it and spreading it to multiple servers. Whenever you do this, you want to be aware of your approximate growth, and you want to accompany as many servers as you think will last you as longest, while also being the most efficient. Now I'm going to do a quick comparison between the NoSQL's Redis and MongoDB. A brief summary: MongoDB is a document-oriented database that is schema-free and is optimized to handle very large data values. This is different from Redis, as Redis is an in-memory data structure that allows developers to perform common operations with minimum complexity and maximum performance. And because of this, they have different advantages and disadvantages. The advantages of Redis are being the speed and the data types. It does offer many different data types, and since it is in memory, mostly running through RAM, it can run at very quick speeds, making it great for social medias. The disadvantages, however, is going to be the storage and queries, especially if your main one being storage. Because it is in RAM, it has very little storage that can be held. The advantages of MongoDB are going to be the performance level and flexibility. Since it is a document-oriented database, it is very flexible as based off the documents can be run and what can be within the documents. However, the disadvantages is because it is using documents, there is both a limited data size as well as those documents use a lot of memory, so there is a very high memory usage. Lastly, I'm going to give a quick overview of when you're going to want to use Redis and some things you may not want to use Redis for. So whenever you're choosing which NoSQL or which language to use, you're going to want to choose Redis when there is a low data latency as well as a low size of data. Because it is within the RAM, it's very quick to get the data out. However, since it is in RAM, it usually has less storage, meaning that you can't handle big data types. It is also helpful when you want to associate a list or a value with a specific key, as it is a key-based database. And you're going to want to also use it when it's majority read access, is when you're having to add more data or more writes. It's a lot harder to do rather than adding just more read commands. Lastly, since it is in the RAM, it does provide real-time analytics, making it great for social media, ad targeting, and vice versa. Lastly, you do not want to use it when you're using AI or machine learning because those heavily rely on massive data structures to have examples to know what to do. And since it is ran in RAM and usually bad with storing big data types, the AI is not going to have much examples, same with machine learning, making it very poor for those uses. Lastly, these are references that we use to gather all this information. If you are interested in learning more on Redis, I highly recommend visiting this redis.io website. They have a lot of great examples, like almost like a mini book type course to help teach you various things across Redis. And overall, it's just a great resource to look at if you're trying to learn more.